There are four types of intermolecular forces, all with funny names. They are ion-dipole interactions, dipole-dipole interactions, London dispersion forces, and hydrogen bonds.
Ion-dipole interactions exist when a solid substance made of ions is dissolved in a liquid consisting of polar molecules. For example, when sodium chloride, an ionic solid, is dissolved in water, a polar liquid, the solid salt crystals break up and form the ions, Na positive and Cl negative. The positive charge on the polar molecule moves towards the negative ion of the salt and vice versa.
The term dipole is just another word for polar molecule. Dipole-dipole forces result from the slight charges on the ends of polar molecules, causing them to stick together. It's the dipole-dipole forces between water molecules that cause bodies of water to have surface tension. These forces are relatively weak because the charges on polar molecules are pretty small. But even the small polar charges are enough to create a tangible force. And when you do a belly flop into the pool, ouch! You definitely notice the dipole-dipole forces between the water molecules. The polar molecules try to hold together.
London dispersion forces are intermolecular forces that result from fluctuating instantaneous dipoles. I'll explain in English. You can't have dipole-dipole forces between nonpolar atoms and molecules, right? Because there are no charges attracting the molecules to each other. But a guy named Fritz London... Who? Fritz London. He figured that since nonpolar molecules can become liquid, there must be some intermolecular force at work between nonpolar molecules. So he came up with this idea of instantaneous dipole movement.
Fritz London figured that even nonpolar atoms like helium might sometimes have both their electrons on one side of the nucleus for just an instant. Old Fritz called this coincidence instantaneous dipole movement. For just an instant, a normally nonpolar atom or molecule is polar. Then, of course, the electrons move and the atom or molecule isn't polar anymore. But when one atom becomes polar for an instant, the force of its electrons on one side repels the electrons on the atom that's next to it, making that one polar for a moment by shoving both of the atom's electrons to one side. This can continue in a kind of domino effect until a whole bunch of atoms are polar for an instant. When this happens, you get a real quick and temporary dipole-dipole type attraction between normally nonpolar particles. London dispersion forces operate between polar molecules too, increasing the attraction between the polar molecules.
We're here in London. The dispersion forces have begun the bombing, pushing our electrons to one side, which makes us polar for just an instant.
Hydrogen bonds are intermolecular forces too. And guess what? They deal only with hydrogen. When a hydrogen atom bonds to a strong electronegative atom, it forms a polar bond. The electronegative atom pulls hydrogen's electrons toward itself. The hydrogen, with its electron pulled away from it, has a tiny positive charge. It is then attracted to an unshared electron on another atom. This attraction, found in molecules like water and hydrogen fluoride, is the last type of intermolecular force.